Good evening, this is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. So today we will continue the same problem, multicollinearity issue. So in the last lectures I have discussed, or you can say I have highlighted briefly the structure of multicollinearity, how it comes to the econometric modeling issue, and what are the shapes and problem altogether, and how we have to go for its solutions. So let me start with highlighting once again this particular problem. So in the last class I mentioned very clearly that multicollinearity is a multivariate issue. The problem will be there when the system is about, you can say, 3 variables at a time, or more than 3 variables. If the system consists of only 2 variables, then multicollinearity may not be means it will not come at all. So that means it will start only either in the trivariate case, or you can say multivariate case. So now we like to see what is all about the structure of multicollinearity. So since it is a multivariate problem, so we will first write what is multivariate problem all about. So multivariate is a system where there is one dependent structures and series of independent structures. We have mentioned in the last class the series of independent is recognized as x1, x2 up to xk. Okay, xk. So the model setup is like this. Okay, so that means the modeling behavior will be like this. So this is supported by a beta 1 coefficient, this is supported by beta 2 coefficient, this is supported by beta k coefficient. For multivariate problems, so we may not have a serious issue, or we should not think much about this beta 0 coefficient, that is intercept terms, that is supporting component. But our major concern on all beta coefficients, that is beta 1, beta 2 up to beta k. So that means the coefficient of independent variables, direct independent variables, not the intercept terms. Okay, so that's why I have not mentioned here anything about the beta 0. So we have to target. So the beta 1 heads, beta 2 heads up to beta k head is our issue. Okay. So now what is all about this multicollinearity? There are many ways you can define the term multicollinearity, but the simplest way to define multicollinearity is that it is having the linear relationship among the regressor or independent variables. So that means it is a problem having the linear relationship among the regressors. So the linear relationship among the regressor, that is the core ideology or fundamental issue of multicollinearity, the linear relationship among the regressor, not non-linear. So we are discussing the linearity issue of regressors. So if there is any such relationship, then obviously this is a issue of multicollinearity. That means the game altogether is like this. So that means obviously by default x1 we are expecting that x1 has an influence on y, x2 has an influence on y, xk has an influence on I. So I for this little bit interesting, so I will put another variables in the system, then we will call it beta 3 heads, beta 3 okay, beta 3 coefficient. So now what is our usual procedures? Usual procedure is to set the regression models. So beta 0 plus beta 1 x1 plus beta 2 x2 continue up to beta k xk, then beta k xk plus u. So obviously by OLS technique we have the estimated models, beta y head equal to beta 0 head plus beta 1 head x1 plus beta 2 head x2, okay, plus beta k head xk. Okay, so this is how the estimated model we have received. So now you see here, see the moment you will have this estimated model, then obvious standard issue is that earlier we are checking the significance of the parameters and the significance of the overall fitness of the models. Okay, so that means significance of parameters, that to beta 1, beta 2 up to beta k, and significance of the overall fitness of the model, that is R square, adjusted R square, then you can say followed by F statistic, etc., etc. So that means it includes ESS, RSS, TSS. So these are the components which will take care the overall fitness issue. And here the beta 0 head, then variance of beta 0 head, beta 1 head, variance of beta 1 head, beta 2 head, variance of beta 2 head, then standard error of beta 1 head, standard error of beta 2 head, then obviously T of beta 1 head, T of beta 2 head. These are the components which will take care the significance of the parameters. So now include with this, so right now what we have discussed is the significance of the parameters, and second is the overall fitness of the models. Okay, let's see overall fitness of the models. So that is the overall fitness of the model, that true R squares or adjusted R square, F statistic, etc., etc. But so far as the multicollinearity is concerned, so we have to check the linear relationship among the regressors. Okay, linear relationship among the regressors. Let's see here. So now that means y is a function of x1, x2 up to xk. Okay, so that means we have to check whether all these beta 1 head, beta 2 head, and beta k head are significant. Okay, significant. So then R squares and followed by adjusted R square has to be statistically high and significant. Okay, statistically high and significant. This is the one issue, this is second issue. Till now we are much concerned about these two issues, but now so far as a multicollinearity issue is concerned, so I have mentioned what is all about this multicollinearity. Multicollinearity is having the linear relationship among the regressors. So now we have k number of regressors, so that means x1, x2, x3 up to xk. So linear relationship means then x1 upon x2, x1 upon x3, x1 upon x4, x1 upon xk, then again x2 upon x3, x2 upon x4, x2 upon x5 or x2 upon xk. Similarly, there may be again x3 upon x2, x3 upon x1, then x3 upon x4, x3 upon x5, then x3 upon xk. Like this, there are various structures you will find. So we like to know whether this association is there or not. If it is not there, then you are in the right track. If it is there, then you are in the wrong track. You have to come to the right track. So that is how we need to have solution, provided your objective must be very specific. Okay, so that means, so third interesting thing we like to observe for this particular multicollinearity problem is that, so covariance of x1 upon x2, okay, or correlation or covariance between x1 upon x2, then correlation between x1 x2, x1 x3, then correlation between x1 x4 like this, then correlation between x2 x3. okay, so it will continue correlation of x2 xk. okay, so this is how we have to first catch all these post. That means we have to apply the permutation combination. You get to know how many such relationship we can have in this particular system, if your system is all about k number of variables. So now for the simplicity, we will restrict our model to only 3 variables, so that we can have the accurate discussions. Otherwise, if you have k number of variables, then the problem is very complex, very pathetic issue all about. So now what you have to do, so for the simplicity we will take y equal to function of x1 and x2. okay, x1 and x2. so let us assume that this is the models we have right now in the system. So now the problem is very simple and very easy to detect so far as a multicollinearity concerned, because here only such relationship is with respect to x1 and x2. okay, so in fact this is also not accurate to detect the multicollinearity, means most of the components we cannot observe from this particular issue. Let's have with it another 2 variables. So let's say x3 and x4. so okay, so now the model is all about where k equal to 5, k equal to number of variables in the system, so independent variables, k equal to 5 dependent variables, and n equal to forget something. okay, so y is y is one dependent variable and x1, x2, x3, x4 is 4 independent variables. Altogether there are five variables in the systems. Okay. So now, so as usual the coefficients are beta 1, beta 2, beta 3, then beta 4. Forget about beta 0 coefficient. Okay, beta 0 is intercept concept, so we are not bothering much about this one right now for this multicollinearity problem. So now what we have to do here is, so we like to highlight the multicollinearity issue. So that means this is one, and second is the R square issue and F statistic issue. Third problem is here. So we like to know in this particular jargon. So we have correlation between x1 and x2. Okay, then correlation between x1, correlation between x1 x3, then correlation between x1 x4. Okay, then correlation between x2 x3, then correlation between x2 x4, then finally correlation between x1 x4, x1 x4 is already there, so x3 x4. Okay, x3 x4. So these are the 6 possibilities are there for this particular setup. Okay, so that means if your game boundary is with respect to y and 4 independent variable, then so far as multicollinearity is concerned, then we have an additional problem we have to observe, or we have to investigate, is that having correlation among the regressors. So that means in this particular setup, so we like to know what is the correlation between x1 and x2, x1 x3, x1 x4, x2 x3, x2 x4 and x3 x4s. By any chance, if all these values are equal and is equal to 0, then there is no such multicollinearity issue. So this problem is absolutely free from multicollinearity. However, if all are may equal, it may not equal obviously. So if it is not equal and not equal to 0, then obviously it is a serious problem. Okay, what you remember one thing. So we know correlation coefficient is denoted as R. For correlation x1 x2, you will call it x1 x2. Then this is correlation x1 x3, we will call it R x1 x3. Okay, so otherwise you can call it R12, R13, R14, then R2, R21, R23, 21, R12 same, because it is symmetric in nature. So 23, R24, okay, R24, then R34. So these are the possible correlation coefficient. These are possible correlation coefficient. So by any chance, if okay, by any chance, if you have like R12, R12 equal to R13 equal to R14 equal to R24 equal to R34. Okay, 3 such possible 1 2 1 3 1 4 R24 R34. Okay, so these are the possible solution: R12 13, then 1 4 2 4 2 4 3 4, and in fact 2 3 is there. So there is another item R23. Okay, if these are all equal to not equal to 0. If it is 0, then no problem. If it is not equal to 0, then there is a multicollinearity. Multicollinearity. Okay, if this is if case 1, okay, if case 2, if R12 equal to R13 equal to R14 equal to R24 equal to R34 is equal to R okay, not equal to 2 3 is not equal to say 0, then obviously it should be equal to 0. Then we can put like this: R12 equal to R13, R equal to 1 4, r equal to 2 4 or 2 3, r equal to 2 4, r equal to 3 4 is equal to 0. Instead of writing this one, it is better to write this one. If that is the case, then it is no multicolinearity. Okay. So that means, so the moment you have a system where y is the dependent variable, x1, x2, x3, x4 are independent variables. So as usual, you have to go for specification test by judging the significance of the parameters beta 1, beta 2, beta 3, beta 4, and in the other sides we have to judging the overall fitness of the model, that is r square, adjusted r square, f statistic, followed by ESS, TSS and RSS, etc. So now in the meantime, so far as multicolinearity concerns, if your objective is to look into multicolinearity issue, then obviously we have to see what is the correlation among these regressors. Then these are the possible correlations, and if it is equal to 0, then obviously there is no multicolinearity. So you have to assume that whatever model you have received, then that model is absolutely best fitted and it can be used for forecasting and policy use. But remember, when these are all equal to 0, then by default, then most of the parameters will be significant and your r square will be very high and f will be also highly significant. But if these particular items are not equal to 0, if you will go by case 1, if all are not equal to 0 and not equal to 0, then there is a multicolinearity. It is a serious problem. Even if you know R2, R2, R13, R14, R24, R23 and R34 all are equal but not equal to 0, then obviously it is also problem of multicolinearity. That means there may be possibility that R12 equal to R13 or equal to R14 may be. So it may be equal, but the value cannot be equal to 0. Okay, if cannot equal to 0, then it is called as a multicolinearity issue. If it is equal to 0, then there is no such multicolinearity issue. So that means so that means what is all about multicolinearity? Multicolinearity is having the existence of linear relationship among the regressor. It is not the it is the degree of association. It is the degree of association between two variables. It does not matter whether they are negatively correlated or positively correlated. Okay, so that means, so we like to know what is the degree only. So that means we know r is always lies between -1 to the +1. Okay, so this is the standard tricks how we have to integrate with the multicolinearity issue. Okay, so this is the standard tricks we have to issue in the multicolinearity angle. So that means when r is simply here represented as a correlation coefficient, but I have not specifically highlighted any subscript here because it is generalized. If it is with respect to first and second variable, then put 1 2. If it is first and third variable, you put 1 3. If it is second and 4, you put 2 4. Like this, you have to abbreviate and you have to interpret accordingly. So now in any case, r is considered as a correlation coefficient. It should be in between -1 to 1. So that means if I will take a range here, so if I will take a range here, then this is 0, this is 1, this is -1. Okay, so now if in a particular regression, so whatever correlation coefficients can possible, that too among the regressors only. So every relationship and every correlation should be tends to this particular circle 0, then obviously there is no such multicolinearity. But if any other point if you will find there in tracking, so then there is a multicolinearity, whether it is left side or whether it is right side. So the nature of relationship is not important for multicolinearity issue. It is the degree of association is very important. If the degree is high, then it is a high multicolinearity issue. If the degree is low, it is a low multicolinearity issue. So how extend in what context we have to, you can say we have to look these matters, or we have to consider this problem. So that is that we have to take care here. Okay, so now let's see here. So our game plan is like this. So this is y and this is x1. Okay, this is x2. Okay, this is x2 and this is you can say x3 and this is you can call it x4. Okay, that means obviously the variables which you have taken x1, x1, this is x2, this is x4. Okay, the variable which have taken, then obviously by default there is some degree of association with y. So it is by it should be, otherwise you cannot go for econometric modeling. That means, so u has a function of x1, x2, x3, x4. So that means there should be some connection with some degree of association between y x1, so y x2, then y x3, then y x4. Okay, so this can be as usual there should be. Okay, so that means in that case you have to put r y x4. Okay, so this is r y x3, then this is r y x2, this is r y x1. So this is how you have to abbreviate. But in this context, this should not be equal to 0. If this should not be equal to this should be equal to 0, then that variable cannot be in the system. Okay, so this is how the system all about the econometric modeling. So that means there is some relationship, correlation must be with dependent to independent variable, but correlation should not be among the independent variables. Okay, so that means x1 x2 and x1 x3, x1 x4, or x2 x3, or x2 x4, or x3 x4, these are not means our concern, it should not be there. So that means the variables which included in the system should be completely independent. Okay, that is the fundamental issue or fundamental agenda of all econometric modeling. So the variables which we have chosen or which we have included in the systems, that two independent variables, should be totally independent to each other. Okay, totally independent to each other. Then the clustering or the influence of independent variable to dependent variable will be very accurate, very perfect, very systematic, and very feasible. Okay, so that means, so we like to know this particular setup, how is it the entire system. So okay, this is little bit very complicated pictures. Okay, because why I am saying multicollinearity has a two dimensional issues. One dimensional issue is the nature of relationship, another dimensional issue is the degree of association. Okay, so far as nature is concerned, either it is negative or positive, so that is not our concern. Okay, so we should not bother about to having the negative association, whether r is negative or r is positive. So we like to know what is the value of r. So is it close to -1, or is it close to +1, or is it close to 0, or is it close to again 0. That means, so the trend is like this. Okay, so the if it is 0 here, this is +1 and this is -1. So that means whether the trend is this side or whether this trend is this side, whether this trend is this side or whether this trend is this side. So these are all correlation coefficient. These are all correlation coefficient among the regressors. So x1 x2, then you say x1 x3, this is x2 x3, this is this is, you can say, r x3 x4. So like this, these are all. So you first find out the correlation coefficient. Let's say correlation coefficient between x1 and x2 is coming 0.7. So you will track here. So this particular component we will call it r x1 x2. Okay, so let's say we will get x2 x3 is minus 0.9, minus 0.9. So this particular angle, so this is called as r23. Okay, so r23. So this is correlation coefficient between 2 and 3. So negative related at the higher level. So we are not bothering whether you are here or whether you are. This is the initial setup. Okay, so whether you are in this direction or whether you are in this direction, that is not our issue. Our issue is the what is this position, where is that position, whether it is close to 1 or whether it is close to -1 or whether it is close to +1 or whether it is close to 0 or whether it is close to 0. That means, so first part of the problem, that is nature of the relationship is not so important, but the degree of association is very important. So far as degree of association is concerned, so obviously the degree will starts from 0 to 1, +1, and 0 to -1. So you will go 0 by -1 and it will go by 0 to +1. So now the moment it will increase this side or increase this side, then the multicollinearity problem will be it will be more and more and more dangerous. Okay, so that means, so the virus will be aggravate accordingly. So the degree of influence, for instance, the boundary is like this. So it will affect first file, second file, third file. So it will automatically highlighted. So if it is very small level, then the problem is not such issue. That means let's say in a folder there are 100 files. If it is affecting only one file, then obviously it is not a serious problem. But if it is affecting 99 files, then obviously it will be serious problem. That is how you have to look into this multicolinearity issue. Okay. So now, so it is the degree which brings the issue of multicolinearity. So now I will so far as the degree is concerned, so the degree may be 0. If it is 0, then no multicolinearity. If degree is very low, then it is a very minor multicolinearity. Okay. If it is very the degree is very or you can say low, then obviously multicolinearity is also low. If the degree is very high, then obviously multicolinearity is very high. If the degree is very high, then obviously multicolinearity is very high. If the degree is extremely high, what is mean by extremely high? That means it is exclusively equal to +1 or exclusively equal to -1, then it is very serious or extremely serious problem for multicolinearity issue. That means this type of situation model, you should not consider that model at all for forecasting or policy use. So you have to, this means close to 1 means two variables are same. So that means we have to drop one variables. Okay. For instance, I will take a series here. So let's say x1 and x2. Okay. So I will put 1, 2, 3, 4 only. Then by default I will put here 6. Then 7s. Then you will put 3, 8. Then I will put here 9. Okay. So this is one series and this is another series. So I really like to correlate it. Then by the instance I will get, I think, positive correlations. Okay. It's a positive correlations, then that to 1 only, because this x1 and x2 are linearly dependent. x2 is the item plus 5, or every case item plus 5, 1 plus 5, 2 plus 5, 3 plus 5, 5. There are many ways such relationship can be. Relationship may be additive, may be multiplicative, may be divisions, may be something. So in that case it will give you signal the linear dependency. So that means the variables are linearly independent should be considered into the system, and that system will be more accurate, more perfect, more practical. Okay. But if if the variables are linearly dependent LD, then obviously the system is very inconsistent, practically not valid, and it is totally infeasible in region. So you have to be bring into the feasible regions. Okay. So how do you go for that particular structures altogether? Okay. So we like to know what is the shape of this degree multicolinearity issue. Since the degree G starts from 0 to extremely high, then obviously multicolinearity will be extremely high. So how does it look like? Okay. So that is our main concern. Let's see here. So let's say for knowing the the complexity of that particular problem with respect to low degree to high degree, then we consider the system where there is y variables and x1 x2 are two independent variables. That is the basic starting point of multicolinearity. So if it is less than that, then there is no such multicolinearity. You see, very interesting. So when you will go for econometric modeling, then you start with the bivariate system. The econometric modeling is useless or cannot be possible when the system is only one variable and having no classification, and the system will be, the root of the system or starting point of the system is that it must have one dependent variable and one independent variable. But in that particular context, multicolinearity is not at all pictures. Okay. It is not at all coming there. So now you add another variable y x1 and x2, then multicolinearity will start adding in the process. So if you add another variable, then it will start another complexity. If you add another variable, then it will start another complexity of multicolinearity. So this is how the problem is extended. Okay. So what you have to do? So you have to show the degree of association. Let's say y equal to here dependent variables. Okay. So this is y and this is x1 and this is x2. So this, in this case, r1 2 is exactly equal to 0. So that means there is no connection between x1 and x2. So in that context this model is perfectly accurate, perfectly fit for forecasting and policy use. So now I will take another model here y and this is x1 and this is x2. So this is, that means R12 there is a relationship, and if I don't know whether positive or negative, because we are not bothering about degree of nature of the relationship, we know the degree of relationship. So if that is the case, let's say it is 0.2 only, okay, 0.2 or 0 minus 0.2. So in that case it is called as a, this is no multicollinearity issue, this is no multicollinearity issue, okay. This is means minor multicollinearity, I can call it minor multicollinearity issue, okay. So similarly there is another issue here, okay. So this is called as a moderate multicollinearity issue, okay. So I will take another case here, okay. So this is very high multicollinearity issue. I will take another case, okay. I will call like this. So this is called as a perfectly multicollinearity issue. In fact, we cannot say perfectly because there is something missing here. Perfectly means it is the two circles which merge each other equally. So in that case, this is x1 and this is x2, this is y. So in that case, it is a very high multicollinearity, okay. So this is very serious issue for econometric problem. This is also serious issue problem. This is in fact also small issue of multicollinearity. This is very minor issue, this is no issue at all. So this is how the shape of the multicollinearity is all about, okay. So now we get to know what is the how do we define the term multicollinearity, what is the nature of multicollinearity, and now we are going to discuss why multicollinearity happens in the occur actually, why multicollinearity occurs in the econometric modeling or in a statistical process. So the reason is that there are many reasons, okay. So one standard reason is that most of the variables in the environment are very interdependent. It is very difficult to find two variables which are completely independent. If it is completely independent, yes, they may be, we will find there are variables which are completely independent, but you know, when you are targeting the causality issue, then obviously we are looking for some interdependence, okay. We are looking for some interdependence, that to dependent to independent only. But you know, if you know within x's, if some x is a function of another x, so that means that itself is regression analysis altogether. Means if you see, I am putting here y equal to function of x1 x2 x3 up to say x4, okay. Then I will find x3 is a function of x4, okay, or I will find x2 is a function of x4. So that means, so x3 can be considered as another y, x2 is considered as another y, because it is altogether dependent side, okay. So that means, so it is it is this structure or understanding only. So the cause is that since most of the variables are interdependent in nature, so by default or by process, natural process, multicollinearity is always be there in the econometric model. But the thing is how whether you will go ahead with multicollinearity or you have to get its solutions. You see, that depends upon your objective specification. If your objective is go for forecasting or predictability, then obviously in that case high R square having low significance errors, low significance of the parameters can be considered as the best models, okay. So that means if you go for forecasting or prediction issue, that times high R square will give you better prediction and better forecasting. But when you will go for reliability of the modeling, that times, so you need to have both significance of the parameters exclusively highly significant and the significant high value of R square and exclusively highly statistically significant for F statistics, okay. So this is how the objective of reliability is concerned. But if your objective is prediction only, prediction and forecasting, then obviously a multicollinearity is not such serious problem, but reliability case it's a very serious problem. But if we go together, then obviously a minor multicollinearity or slightly moderate multicollinearity is not a serious issue. You have to go ahead with, because it's very difficult to find a system where all the independent variables are totally independent. So there may be some kind of interconnections. Okay, so it's very difficult. So that's why by default there will be some relationship, but that relation should be very at the minor level. Otherwise, if it is a high level, what is the point to take or to consider two variables differently? So it has to be one variable only. For instance, in economic environment, or you can say management environment, we have GDP and per capita GDP. Okay, so GDP is considered as a sometimes is a variable, and per capita GDP is sometimes considered as a variable. Both have different interpretation, different structures, but sometimes their impact more or less impact may be some way contradictory, or you can say other way around. For instance, for instance, you may find some kind of relationship between GDP and per capita GDP, because per capita GDP is derived from GDP. If per capita GDP is derived from the GDP, then obviously GDP is derived from per capita GDP, because per capita GDP is nothing but GDP by population. So this is how, means I am just highlighting one example how multicollinearity can be serious issue. For instance, another case you take, what is the impact of FDI on stock price, and another side, I will take another variable, say x1, which is represented as FDI as a percentage of GDP on, you can say, stock price. So FDI is one part of one variables, and FDI as a percentage of GDP is another variable, because the game plan is completely different. FDI there is variables, and FDI by GDP, then the game plan is completely different. But somehow if you integrate FDI to FDI percent as a percentage of GDP, means if in a particular system, if I use stock price as a dependent variable and FDI as a percentage of GDP is another two independent variables, then I definitely find there is some linearity between FDI and per capita this FDI as a percentage of GDP. So that means in that system will be perfectly okay. So whether means if you use only FDI, or you can use FDI as a percentage of GDP, either one you can use, then the model will be perfectly okay. But if you go with two variables, then obviously the complexity will start, and it will be serious multicollinearity, because for that I am very beginning I have mentioned that your theoretical knowledge must be very high, or external knowledge must be very high with respect to various theories and various statistical knowledge, various mathematical knowledge, then you will enjoy this econometric modeling. Otherwise it is very contradictory. This type of issue, if you have no such theoretical knowledge or outside knowledge, then you cannot detect particular variable whether they are correlated, because we know the definitions and we know the setup. That's why we are saying, for instance, if there is two variables, say I will call money supply, and I will use the term M3 for India point of view. Okay, so money supply M3 is money supply, because money supply has a different groups. So M3 is one of the such groups. So if you will take money supply, and if you will forget about data, you can artificially generate data, but if you put money supply and this M3, then obviously there will be some kind of multicollinearity. Either you use, or instance if you go by money supply, then obviously you will find there is some data with respect to M3 and M2, and some data with respect to M3, but both will come under money supply. So now if I am fitting any models with respect to M2 and M3, then obviously there is some connection between M2 and M3. Either you will go by M2 separately, and go with Y with M2 and Y with M3 separately, and I will check it which one is the best for the best fitted. So then accordingly I will consider that variables. Otherwise if you will go together with Y, M2 and M3, then obviously there is a serious multicollinearity. This is how this means this is one of the strong cause for issuing multicollinearity problems. So another problem is that introducing lag in the system. So we will discuss detail when we will go for time series modeling. So when you will introduce lag in the system, then by default it will generate multicollinearity, which I have highlighted very clearly in the last class. Okay, so then mathematical manipulation, mathematical formulation also creates multicollinearity problem. So you must be very perfect how you will go for mathematical formulation of this particular problem. Okay, so then inclusion of unnecessary variables in the system will also have a multicollinearity problem. So again, with respect to sample size, a low or a high can also multicollinearity problem. Econometric modeling is sometimes it's a fuzzy game. For instance, take a case of cause of multicollinearity with respect to size of samples. If the size of sample, then sometimes there may be some collinearity, but later stage these two variables will diverge themselves. Then obviously there is no such multicollinearity. But there is another interesting problem. First they will diverge, then after a certain point of time they will converge. So that means if you will take total time length, then you will find there is some multicollinearity. But if you will see, if you will classify this structure into two different shapes, for instance, for a particular point of say 952, you can say 2000. For instance, I have 952 2000 data point. Okay, so now first they diverge like this, then after particular point of time they will converge. Okay, so that means you make the division here. You take this one along, you take this one side and this one another side, then obviously you will find there is no such multicollinearity. But if you take total sample periods, then obviously then there is a serious multicollinearity problem. So that means sample size itself will make the game interesting, or it can also generate problems. So you must be very careful how you have to choose the sample size, whether you have to go for high sample size, or whether you will go for low sample size, or whether you will go for optimum sample size. So it is depending upon the structure how you have to coming in with that pictures. Okay, this is how the causes of multicollinearity. Then what are the consequences of multicollinearity? So consequences is that, you see, we have already discussed when we will go for when we will go for overall fitness of the goodness fit of the models or best fitted models, then obviously we will go by significance of the parameters, but the parameters should follow some principles which we call is the blue. Okay, best linear unbiased estimator, that is called as a best linear unbiased estimators. Until unless you receive this properties, that means the estimated parameters which you have received in the systems should be unbiased, should have minimum variance, and should be very consistent. Okay, should be very consistent. What is unbiasedness? Means the different bias should be equal to 0, that is the difference between expected value and true value. Okay, like this means unbiased means E beta head should be equal to beta. Okay, so now if take another we will take another parameter, say beta star head. If variance of beta head is less than to variance of, you can say, beta star head, then beta is considered as the best parameter than the beta star head. Okay, similarly consistent, this is called as a minimum variance property, this is unbiased property. Similarly there is if you club together, then it's called as a consistency property. That means when n stands to infinity, then that means if you increase sample size, then there is enough chance that expected value of particular parameter should be equal to true value. That means if for this instance E beta head equal to beta, and in the second instance variance of beta head should be less than to variance of another beta head, and variance of beta head should be close to 0 when n stands to infinity. That is what consistency property. If all these properties are maintained, then the estimated model can be considered as the best fitted model. But if all these properties are going against, means if it is not unbiased, if it is not best, if it is not having minimum variance, if it is not consistent, then obviously the model has to be redesigned. And one such problem is multicollinearity. If multicollinearity is there, then it will affect the unbiasedness property, it will affect the minimum variance property, it will affect the, you can say, consistency property, and so many other things are there, linear in nature. The estimator should be linear in parameters, etc. Okay, So this is how you have to observe. So that means, so for the consequence is that, so involvement of multicollinearity or the presence of multicollinearity will lead to make the system deviation from the blue. So it will take diverge from the blue component. So as a result, if it is diverging from the blue, then obviously, so the model cannot be considered as the best. So you have to find out the solution how they will converge to the blue. That means this should go, you have to choose a system where all these parameters should be, follows the blue property, the best unbiased estimators. Then you can use for forecasting and policy use. Okay, so this is how the major consequence of the multicollinearity problem. So then next is how to detect. Okay, so far as the detection is concerned, I have already mentioned the way we have discussed. One of the standard tricks how to detect the multicollinearity is to correlate among the regressors. Suppose there are 5 variables, so accordingly you have to find out x1, x2, x1, x3, x1, x4, x1, x5. Similarly, x2, x3, x2, x4, x2, x5, x3, x4, x3, x5, x4, x5. These are the possible correlations. Then you check whether all these correlations are 0 or not. If it is 0, then it is free from multicollinearity. If few are 0 and few are not 0, then obviously there is some kind of or multicollinearity is there. Okay, so if some kind of multicollinearity is there, then you have to check what is the degree of that multicollinearity or degree of association. If it is high, then it has a strong negative impact, okay, and the best fit of the model. And if it has a minor relation, degree is very minor or very low, then obviously the impact is very less on that feasibility of the models. So this is how we have to detect the structure of multicollinearity. This is one of the standard detections, standard measure how you have to detect the multicollinearity. There are as a statistician or econometricians, there is lots of various clues how you have to detect the multicollinearity. For a standard reason is that very beginning in my first lecture of this multicollinearity, I mentioned that, so we look for two specific objective, that is significance of the parameters and significance of the overall fitness of the model. So now for significance of the parameters, then we are looking for our objective must be all parameters should be highly significant, R square should be high, and f should be statistically or highly significant. But that is the requirement, but ultimately we have two different other options, that is few parameters may be significant and others are not significant, and R square will be high and f will be very high. This is one situation. And another situation, having low R square and having low R square and having few parameters are statistically significant, then it is also, you can say, problem of multicollinearity. So in that context, what you have to do, you have to go for lots of permutation combinations, and you have to find out whether there is a multicollinearity and what extent the multicollinearity is all about. Okay, so this is how you have to detect the multicollinearity. Once very standard thing is that if your if your parameters, all parameters are not statistically significant, and R square is coming high, then this is one of the inspection method how you have to observe or how you have to expect that there should be multicollinearity. But you have to go again every time by detection criteria how to detect the multicollinearity. In fact, we sometimes econometricians sometimes use the partial correlation coefficient is the detection measures. If high multiple correlation and low partial correlation coefficient, then it also indicates you that there is a problem of multicollinearity. This is how you have to go for detection criteria. So now, so far as the solution is concerned, there are a number of solutions you can find out this multicollinearity issue, and one of the standard solution is either you go for optimum sample size, or if there is still there is a multicollinearity problem, so either you increase sample or decrease sample till you get the models which is free from multicollinearity. This is one of the standard trick how you have to go for solution. Okay, and second thing is you check whether the variables are closely related by inspection or by theoretical knowledge. If you know that few variables or two variables are closely related to each other, it is better to drop that variables. Then if it with rest of the variables, there is enough chance that the model will be best fitted, where all parameters will be statistically significant and overall fitness will be very high. Okay, so this is another way how you have to get the solution. Okay, besides there are standard like this. There are so many tricks how we have to get the solutions with respect to different cause, then solutions will be multiples in natures, but one standard criteria is that. So, you have to first point out why this problem usually happens, and for accordingly you have to apply this solution criteria. So, that is how you have to solve these multicollinearity problems. So, now with this sometimes there are different techniques. If you apply, the problem of multicollinearity can be solved. I have mentioned that econometric is a very fuzzy game. Sometimes by the use of different techniques, the multicollinearity problem may be automatically solved, because the technique itself will take care of this multicollinearity issue. This is very interesting, and in fact today's world we are in process of software, various softwares. So, this is software Raj. So, if you apply different softwares with different application, different techniques, then the problem of multicollinearity will be automatically solved, and you will get the best fitted models. Okay. So, now with the before ending this particular class, so I like to highlight two things here. So, you see, so far as the multicollinearity is concerned, you start with your specific objective specification. If your objective is predictions only, then obviously multicollinearity is not a serious issue. But if your objective is reliability issue, then obviously multicollinearity is a serious problem, and you have to first solve the multicollinearity, then you have to use for forecasting. If that is not the case, then obviously it will go other way around. With this, we will conclude this particular session. Thank you very much. Have a nice day.